All right, so I'm going to do a couple questions from the factoring portion of the exit exam review. I'm only going to do probably about 5 factoring problems here for you. The rest of them you can ask your teacher for help, check the key on Canvas, or look back through some old notes. But I wanted to give you some pointers on a couple that were maybe a little bit more challenging. Number 1 for factoring, 8 minus 27w cubed. There's only 2 terms. You always look for a GCF first. There isn't one. We notice that there's a w cubed, and 27 and 8 are perfect cubes. So we're going to use the SOAP method of factoring a cubic function. Here, some people wanted to flip-flop these because normally we have the term with a variable first. There's no need to do that. You can go ahead and do SOAP when it's set up with the constant and then the variable. So remember that you're going to have 2 sets of parentheses. The first set has 2 terms, the second set has 3 terms. In the binomial part of our factored form, you take the cubed root of 8, which is 2, and the cubed root of 27w cubed, which is 3w. I'm going to put the signs in later, the pluses and minuses. Now, to fill in the trinomial, the first blank, you square the 2, which is 4. The last blank of the trinomial, you square the 3w. 3w, the quantity squared, is 9w squared. And to fill in the middle, you actually multiply 2 and 3w together to get 6w. Now for your signs, remember SOAP stands for same, opposite, always positive. So you put the same sign between the binomial, opposite sign. Oh, I did that backwards. That's not the same sign. You put the same sign, a minus, between the binomials, the opposite of that sign here, and always positive at the end. That is your fully factored form. Remember, the trinomial will never factor. Okay, we're going to skip down to 7. We'll do number 1, 7, 8, 9, and 11. So 7, I have 3x to the 4th minus 12. Always start by looking for a GCF. I do have one here, which is 3. If I factor out a 3, I get x to the 4th minus 4. Now, when you look at that, you're actually going to continue factoring x to the 4th minus 4 using the method of difference of squares. X to the 4th and 4 are both perfect squares. The 3 comes down. And then when you factor here, the square root of x to the 4th is x squared. The square root of 4 is 2. One term needs a plus, one needs a minus. You can't factor anything anymore because 2 is not a perfect square, so that would be your final factored answer. When I move to 8, I have a squared plus 64. Both are perfect squares. However, because there is a minus in the middle, that means that this is prime and not able to be factored by the difference of squares. So remember, you can only use the difference of squares when you have a minus sign, because subtraction is difference. Number 9, 3x to the 4th plus 16x squared plus 21. Even though this is a quartic degree 4 polynomial, it has 3 terms, so we're still going to use split the middle here. All right, so what you're going to do, you look for a GCF, there isn't one, so we're going to multiply 3 and 21. That gives us 63. And 2 numbers that are going to multiply to 63 and add to 16 are going to be 7 and 9. All right, so I'm going to split the middle here. 3x to the 4th plus 7x squared. Now I have to use an x squared. I'll finish writing and then I'll explain it. I have to use an x squared here in the middle term because I'm splitting up 16x squared. 7x squared plus 9x squared is 16x squared. From there, I do grouping. Group the first 2, group the last 2. Pull out a GCF. And then the GCF in the second one would be 3. Great, and now you should be able to see the final factor form will be x squared plus 3 and 3x squared plus 7. Neither of those factor any farther. Neither of them have a minus sign. You can't do difference of squares, so that would be it. The last one I want to look at is 11. This is actually also going to be difference of squares. We did some like this. I'm sorry, too early in the morning on a Sunday. Not difference of squares. We need to use split the middle here. There are three terms. There's no GCF. I can actually split the middle just like I did on the previous problem in number 9. So what I'm going to do is I'm going to multiply the 4 and 25. I'm going to ignore the variables for a moment. I'm just going to deal with the numbers. I need two numbers that multiply to 100, 4 times 25, and add to negative 20. Well, that would be negative 10 and negative 10. When I split the middle here, I'm going to keep the 4x squared the same, the 25y on the end the same. The middle term, because it's minus 20xy, these two terms that I used to split the middle, the variables need to be xy. So it would be minus 10xy, minus 10xy. And now you should be able to split the middle the exact same way we just did. So we're going to group, or to finish the factoring process. So the GCF for the first one would be 2x, and we'll be left with 2x minus 5y. And then the second one here, I want to pull out a negative because the 10 is negative. Pull out a negative 5y, which will be 2x minus 5y, which is the same as what I had in the other parentheses. Looks like my factored form will be 2x minus 5y times 2x minus 5y. You can leave it like that, or you can condense those to be 2x minus 5y, the quantity squared. Either one of those answers is perfectly correct. If you need help on any of the other factoring questions on this page, again, check the key or ask your teacher for some help.